Hello friends, welcome to another video, and this question is asked in December 2009, and the question says that a 2 voltmeter is connected to measure a input of a balanced three phase circuit, indicates 2500 watts and 500 watt respectively. Find the total power supplied and the power factor of circuit. So we need to find a total power. That's important. We need to find a total power and the power factor of a circuit, and the condition to which we need to find this two things is when both the readings are positive. Okay, so both the readings are positive, and second condition is given to us that when a letter reading, that is letter means the next reading is obtained after reversing the connection. Okay, every time it is said that a later reading is obtained by reversing a connection means a negative. Okay, so the later value of the voltmeter is used as a negative. Okay, so this thing you need to remember while solving the problem. So before starting the problem, uh, we should know the formula of total, how to obtain a total power, and how to obtain a power factor for these two conditions. So the formula. So the total power, that is PT, is just obtained by adding W1 plus W2. And what is W1 and W2? The voltmeter reading 1 and voltmeter reading 2. So total power, to obtain a total power, it is just simply the addition of reading of W1 and W2. Okay, and the second formula we need to use is obtain a power factor. And power factor, what is the formula for power factor? And it is just a cos phi is the power factor. Okay, so we need to find this cos phi equals to question mark and the total power. Okay, so before before starting, the first condition for which we need to find this two thing is first condition, case 1 is when both readings are positive. Okay, so the W1 equals to 2500 watt and W2 equals to 500 watt. So the both readings are positive. The first thing we need to find is total power, that is PT, and the PT is given as W1 plus W2, that is 2500 plus 500, which gives us 3000 watt. So the total power is 3000 watt for the first condition. Second thing we need to find is power factor. Okay, the power factor is cos phi, but we don't know the value of cos phi. Sorry, we don't know the value of phi. As soon as I get to know the value of phi, I will easily find the cos phi. To get the value of phi, we have a formula to find phi. To find phi, we have a formula, that is tan 5 is equals to root 3 times W1 minus W2 upon W1 plus W2. Okay, so by this formula we can easily find a phi, which is a desire. Okay, by taking tan to opposite side of equals to, which becomes tan inverse, that is phi is equals to tan inverse of root 3 times W1 minus W2 upon W1 plus W2. Okay, so the phi is given as tan inverse of, just substituting the value of W1 and W2. Remember, the case is that both the readings are positive. Okay, so remember this condition by so we get root 3. What is W1? W1 is this, that is 2500 minus, what is W2? W2 is 500, so substituting 500 upon again 2500 plus 500. Okay, so after this it's just a simple addition, and we get tan inverse of root 3 times 2000 upon 3000. So the 0 0 get cancelled, and if you solve this, and we will get a 5 equals to tan inverse of 1.154, which is equivalent to 49.106 degree. So we get the answer of phi, that is 49.106 degree. Now just put the value of phi in cos phi to get a power factor. Therefore power factor power factor equals to, power factor is cos phi. Now we have a value of phi, that is 49.106, and by putting this value you will get the power factor as 0.654. So we get the power factor for our first condition, that is when both the readings are positive. Now for the second case, case 2, we know that it is said that the later reading is obtained after reversing means negative. So we will consider, that is W1 is equals to 2500 watt, and W2 is equals to minus 500 watt. Why minus? Because it is given in the condition that the later reading is obtained by reversing means negative, hence minus 500. Okay, again the same procedure you have to follow, but this time whenever you see a W2 you have to put minus 500. Okay, so the first thing we need to find is total power, that is PT is equals to W1 plus W2, which is, what is W1 is 2500 plus minus 500 W2 value, and which gives you 2000 watt. So the total power is just a 2000 watt. Okay, now we need to find a power factor. We need to find a power factor which is cos phi. Okay, again we use the same formula for to find a phi. Okay, which is used previously. Phi equals to tan inverse of root 3 into W1 minus W2 upon W1 plus W2. Okay, now this time we need to put the value of W1 and W2, that is tan inverse of root 3. W1 is 2500. Now it is already minus, and minus 500 will become plus 500. Okay, upon 2500 minus 500. Now we will get a 5 equals to tan inverse of root 3 into 3000 upon 2000. Again 0 0 0 will get cancel out, and we get a value of phi. We'll get the value of phi as 6 tan inverse of 68.94. So now it is just a matter of putting phi in cos phi, that is power factor is equals to cos of phi, which is cos of 68.94, which gives you power factor is 0.359. This is the power factor. Okay, so thank you.